All right, so we're gonna go ahead and get started. Thank you guys so much for joining me tonight as we talk with people about how to tap into your math genius. I'm excited for us to come together again to spend a couple weeks. So I've been blowing the group chat up, trying to get these conversations going. So now we are coming together so we can actually have that dialogue here face to face. So without further ado, can you guys just introduce yourselves, just in case somebody comes across this that does not know one of you?
Akil Parker, math teacher, 19 years, adjunct professor at Cheney University, the past 5 years, teaching math, teaching the new math to future educators, and founder and CEO of All This Math, where I'm trying to improve the relationship between math and the Black community, and a father of 3.
Man, I think we need the machine with the hand clap noises for that. We need the machine. I'm Dana Harris, father, educator for nearly 20 years, and I am the chief academic officer of Young Gurus Math Tutoring, an online tutoring platform. I also have a YouTube channel as well. Young Gurus Math Tutoring. Check it out. A whole lot of video, whole lot of content, whole lot of math-ish going on.
I love that. Chief Academic Officer. I know that's right. All right. So I am Lanisha Boone. I am a district math coach by day and really math coach by day and night, because I'm coaching the children too, the same way I'm coaching the teachers. So I absolutely love math. I've said that time and time again. I can just spend so much time just getting lost in looking at problems in different ways and trying to figure out different ways to make it come across to children. So I want us to go ahead and jump into tonight because I think it's going to be, I feel like it's going to be a good one. I want us to start off tonight talking about some questions, though. I want us to start off tonight talking about some questions. So the first question that I have for us to ponder over is there such thing as a math person? And I've heard Akil talk about this before. I am asking this question because I was listening to a podcast recently and they made a statement about it, and I'll share that after you guys answer.
I don't think there's a such thing as a math person. I think you can be taught how to learn and understand mathematics, but it's simply based off of repetition, practice, failure, mistakes, and all of that stuff.
Mm-hmm. Okay.
I agree with Dana. In the context of when people ask this question, but I would say that yes, there is a such thing as a math person, but I think every person if you're a person, you're a math person. Mm-hmm. So I would take it there. And I've heard people say that. When I heard somebody say that, I'm like, yeah, that makes sense. You're a person and you can do some basic math. That makes you a math person. I think I pulled out this book that I pulled out a couple of sessions ago, mm-hmm. The Secrets of Mental Math book. The reason I pull it out is because when people can do stuff like this that he outlines in this book and highlights, if they don't tell you that they know the tricks and they know the algorithms that somebody taught them, or maybe they even discovered on their own, if you witness that and you're a person that might not be as confident in your own math ability, you might sit back and say, oh, see, they're a math person. Mm-hmm. Not knowing, like, no, somebody gave them the cheat codes. Somebody could have just as easily gave you the cheat codes and you know how to figure out, this, 35 squared off the top of your head. Because it's a trick to it. Mm-hmm. So, but a lot of people don't know that, like, it's a lot of tricks and, with certain things,
Gotcha.
There's a lot of that comes into play too.
Okay. So as I was mentioning, I had listened to a podcast recently. It was actually the podcast that Dana referred to us in the group chat with the math guru. Uh-huh. So it's called Math Therapy. And so she had this guy up here, and I think his name is Dan, but I can't remember his last name. It's not Dan Meyer though. And he was talking about this whole idea of a math person. And he was like, he doesn't feel like there is a such thing as a math person, but his thought process was a little bit different. So he was like, there are people that says that everybody has the potential to be a math person, and he feels like he disagrees because I think he was looking at it from the standpoint of going all the way up the levels of mathematics, not necessarily basic mathematics or elementary, middle school, high school mathematics. I'm thinking he's thinking along like someone who's a research mathematician or something like that. But he felt like sometimes there's a lot of talk that teachers are doing and thinking that it's going to have an immediate impact with how a student engages with mathematics, but it doesn't. And I think that was more so his point versus whether you can or cannot be a math person, is that we're saying a lot of things, hoping that whatever it is that we say is going to change the way a child looks at something, but it's a lot more that has to be done. And I think that was his point. So one thing that you were talking about, Akil, was students knowing tricks. You know, that make my eyes cross a little bit. But that leads me.
I was waiting for it. I was waiting for it.
That leads me to my next question, though. How do we build capacity in older students? So a lot of the conceptual stuff, and you can talk to it because you're teaching the methodologies or the method classes or whatever, you can talk to it. I think a lot of the stuff that we teach is for foundation. And if a child has already gone past that, now how do we go back and help them develop those skills as we are teaching them grade level content?
Well, let me say this though. Like when I'm using the term tricks very loosely.
Okay.
Because when I think of tricks, I'm thinking of like everything is in there. Like distributive property to me is a trick. You know, breaking numbers down, like, you know, so we have a number that, you know, ends in 0 and another number, so to make the multiplication like easier to do. So I'm thinking of all that also as well. What was your question again?
So how do we build the capacity in older students? And I wanted you to kind of talk about the fact that you're teaching these method courses, and a lot of that stuff is foundation based. So after a student has progressed past that grade level, how are we able to build their capacity, their numeracy, so that they can build those skills and then apply it to the grade level stuff?
So yeah, to use the corporate jargon, we gotta circle back.
Okay.
You know? And you know, because when we confront it while we're trying to teach the more the content that's on their level, so to speak. Like I just finished a tutoring session. Young sister, she's a freshman in college, and she's taking, I guess, a college algebra course, and we going over, like, you know, trying to find the domain of a function. And I'm trying to explain it to her, like, conceptually, like, listen, like, you know, it's like if somebody come over your house, you say, listen, you can stay at my house, you can eat anything you want in the refrigerator except for this. This is my favorite. You can't have this. That's your domain restriction. You are restricted from eating that. Don't touch that. Everything else, whatever, cabinets, refrigerator, whatever. So you know, I'm like, okay, it's a fraction. What happens if your denominator is a 0? What's going to happen? She didn't really know. She couldn't really tell me. So I'm explaining it to her. I'm trying to be as conversational as possible. I'm like, look, like, you know, that's a bad thing. You know, if your denominator is 0, it's undefined. That whole expression is undefined. If your denominator is 0, right? We can't have 3 over 0, 10 over 0, because we can't divide by 0, right? I didn't get into the mechanics of the division and why that is, but, you know, in the interest of time, but we kept going. And then I'm like, all right, so what you're going to do is you're going to create an equation. The denominator happened to have been x plus 9. So I'm like, okay, x plus 9 equals 0. And I'm like, solve for x. Didn't really know how to do that. I think she knew, but I think she was nervous. So she might have, like, you know, not been able to really process. So I walk her through how to solve for x. She gets -9. Then I'm like, all right, now let's see what's going to happen if x is -9. So throw the -9 in there, plug it in, replace the x with -9. She had a deficiency with arithmetic with negative numbers, because I'm like, what's -9 plus 9 gonna give you? So first she's like, I don't know, 18. Like, nah. Then she's like, -18. Like, nah. So then she says 0. I'm like, yeah, it's 0. So then we established that, you know, these are fundamentals that we need to go back to. But with her, it's a little different. She's a college student, so young adult. And I'm like, you're gonna have to like figure out, just practice, practice your arithmetic with negatives and positives, and even your multiplication and division at the same time. Because earlier we talked about how, with in algebra, 2 wrongs make a right? Multiply the 2 negatives, you get a positive, right? But be careful, because that rule doesn't apply to addition and subtraction. Because you got one set of rules for addition and subtraction, you got another set of rules for multiplication and division, if you want to look at it that way, right? But I guess so to your question, like when it's recognized, then I guess like pivoting, I guess the what I like to do is, if I can, pivot and just zero in on that skill, because it's got to be addressed. Because if it's not, then you're not going to really be able to advance. And the sister, she's a volleyball player, so then I was able to like try to make a parallel to her, like, listen, like, there's certain fundamentals that you can do. You're an advanced volleyball player, been playing volleyball for years, right? But if somebody asks you, like, how do you serve a volleyball, it might be difficult for you to really tell me, because your muscle memory will kick in. You probably don't think about doing that or how to do that. But if you want to go to these like advanced clinics or whatnot for advanced players, if somebody coming in and they don't know how to serve a volleyball, it's like they're gonna send you home. Like, we can't do the advanced stuff, because you got to bring this skill to the table already. And so she kind of understood, like, once I drew the parallel between, like, math and volleyball and fundamentals, the importance of fundamentals and being strong in fundamentals. Because what I also was telling them was like, look, you see how, like, this is why a lot of people get frustrated with math and want to quit, because you're spending too much time on portions of the problem that should not require that much time. Right. So it makes you like, and you're not, and I guess rightfully so, like, you're not supposed to be spending that much time on figuring out what -9 + 9 is. Like, that stuff you're supposed to just know, so we can get to the other more, I don't want to say challenging, but more involved parts.
Yeah.
Of the concepts of finding the domain of a function.
Right. I want to interject real quick before you chime in, Dana. So I wrote down some of the things that you talked about in that problem. You mentioned domain, so now we're talking about vocabulary. You mentioned solving an equation. You mentioned integers. And this is a college student, which means this is a semester-based class. So she has a very small amount of time to pick up on all of these skills that are unfinished, all these unfinished learnings, so that she can be ready to move on. And I mean, thinking about how fast it's going to be moving. So I guess I'm asking this question about building the capacity, because the teachers at all levels have a finite amount of time. So you're talking about the vocabulary, the different skills that they need in order to even unpack the question that we're talking about now. We're talking about spanning across several years. And I don't know how long your tutoring session, but I'm gonna pause there. Dana, let me know, how do we go about building the capacity in older students?
So a couple things that I wrote down is number one of the things that's important is to identify their learning style.
Okay.
So that the information can stick. Repetition and going back to the basics. And what I found in this, I start with the solution, because what I found in this is that, with the Wi-Fi babies, many of them don't understand, like I said the other week, they don't understand the capacity that the mind has. And so because they have their gadgets, their cell phones and everything else, Google, calculators and things, to them it's simpler to use a tool. You know what I'm saying? But as I always say, the tool is only good as the operator. If we put the wrong thing in the calculator, it's going to give us the wrong thing back. And then just practice the basics. A lot of the older students, they get kind of apprehensive when you're working to do that, because in their mind, it's like, yo, I'm in the 8th grade. I'm in the 9th grade. I'm not practicing addition and subtraction. You know what I'm saying? That college student, well, why do I need to practice addition and subtraction? Well, because it's going to be a major part of your class. And I agree with the kill 100% in regards to students getting lost in the weeds. You know,
Yeah.
a lot of students, by the time they get to 8th, 9th grade, I always like to use the example of solving equations. So when we solve when you have that x minus 9 equals 0, or x plus 9 equals 0, like, to us it is muscle memory. You know what I'm saying? But I think one of the things that helps build the capacity, like I said, is you got to identify their learning styles and then go back from the beginning. But you also got to kind of build a relationship. You mentioned the finite amount of time that we have. So that gives me another thought process, and it's the fact that it's not solely on the teacher. You know what I'm saying? After they get to a certain grade level, it actually is never solely on the teacher. You know what I'm saying? Because even high school students, we like to think that they're mature after 9th grade. Um, but at the same time, if they haven't been brought up in an environment where education is celebrated, where learning is celebrated, and things like that, then it's going to be more difficult for that student to really go back and enlarge their capacity. You know what I'm saying? It's always possible, but it also becomes a matter of effort. It becomes a matter of adult support outside of school. So those are the main things that I think about.
I'm trying to remember. I wish I was trying to tag my mom so she can come up here. She was telling me about some statistic the other day, and maybe one of you guys are familiar with it. She was saying that I don't know if there was like a study done or some research, some data census, whatever was completed, and there was some portion of the population that only had up to a 6th grade proficiency in math, and then I think an 8th grade proficiency in reading. And so she was saying that what she read, the newspaper articles are written with that in mind. And then the conversation about around the data, wherever she was, the conversation around it was that if whatever that percentage was, because I can't remember, if that percentage of parents only has up to a 6th grade proficiency in math, now they are incapable of really supporting the children beyond that. So, and we've talked about this idea before. I've heard Akil talk about it several times. It's just about that education happening at home. The teachers, I mean the parents being the teachers, the primary teachers, and not necessarily depending on the schools to do everything. And I feel like what I'm hearing in what you both are saying is this is absolutely necessary, because again, there's so little time in the classroom. If we're talking about 45 to 90 minutes in the classroom, I don't have enough time to learn your learning style, to be honest with you, especially if I got a class full of 30 students. Your specific learning style, I don't have enough time to do that. And then I already made a list of 4 things, 3 to 4 things that this student needs help on. When am I going to find time to help Lanisha on those 4 things when I got 29 other students that I need to help as well? So we got to go back to the parents being the primary educators, but now we got this other hurdle, that 6th grade math proficiency. So now, how can we support parents in them supporting their kids at home?
Real quick, let me say this too, because for the teachers watching this, that learning style thing is something I like to do on day one. Day one, even in high school, we not, depending on the class, some classes, if you're in pre-calc, you might do a unit day one, or I've seen people that do a unit day one. I'm not that person. Day one, we're gonna chop it up. I want to get to know y'all. Y'all gonna get to know me. So the one piece of work we might do is that learning style survey. But when you say how do we get back to parents being the primary educators, I mean they have to. You got to be a progressive parent. You got to be a parent that really has a mindset, a growth mindset. At the end of the day, because if you don't, then you're modeling the same thing to children. And it's not to say that that's a bad thing. One of the things that I tell my students now is that you're going to have to learn information no matter what job you do when you get out there in the real world. Whether you got a job that requires a degree or whether you got a job that you just need a high school diploma, or whether you got a job that you just have to have a minimum age. Any job you go work, you're going to have to learn something. If you want to be an entrepreneur, you're going to have to learn something. So there's always going to be a learning curve. And so with that fact being known, I think one of the things that can help parents make that shift is getting them to understand, like, from day one, you teaching your children things when they're infant, right? You know, you just talking to them, this and that. They start moving a little more. They roll over and crawl, things like that. They're learning from day one. They're collecting data. We just got to find cool ways to throw that data in there. Someone asked me, I had a conversation last night, and they were saying they have a son going to the 2nd grade and said he loves math. But when it's time to do reading, he gets mad and starts like talking trash to the teacher, like, man, I don't want to do ELA. I want to do math. You know, and I encouraged her. I said, well, the cool thing about that is that if he does well in math, he's gonna get the reading interpretation. And so we were talking about things that she could do to help him, you know, have a more of a desire to read. I said, well, what kind of books do you buy for him? She was like, I got all the Dr. Seuss books and this and that, and he don't like them. I said, okay, so is he into superheroes? She said, yeah, he loved that Spider-Man. She said, whenever I take him to the bookstore, I just want him to get comics. I said, bingo. I've dealt with the same thing. DJ, after a while, he got tired of getting the storybooks. He only wanted to get comics. And I was apprehensive about it at first. But when I realized that DJ was able to interpret these little bubbles and these conversations, and he could stand by like 8 years old, he could have conversations with grown men about what was going on in the comic, I use that as a stepping stone and a building block. I say that part to say, if a parent wants to really be their primary educator for their child, you do the things like Akil is talking about in his videos. Your child love to cook? All right, well, check it out. We're going to talk about the math in this recipe. Your child loves to, if you want them to read more, hey, let's get to reading I mean, they ain't reading cereal boxes, but you know, when a kid first learns to read, they want to read everything, and we have to be willing to take those moments and really, really like find every little teachable moment that we can, because it doesn't have to be like schoolwork. It's just any little teachable moment, whatever it may be, whether it's character, whether it's academic content, whatever it might be, there's always room for a teachable moment.
You just made me think of something about just like the marketing of parents educating their children. Like, we always see like the videos, especially like, and, you know, we're going to see a bunch of them in August when school's about to start up again, because it happens every year. You know, the whole, like, you know, if Johnny has 5 apples, right?
Yeah.
So what gets constantly, we get flooded with the deficiency of parents in terms of being able to educate their children. We don't never see the videos where it's like, there are competent parents that are proficient that may not even be math teachers, may not have a so-called strong math background, but are able to sit down with their children and be effective and effectively help them with their homework. You know, and that's never marketed. We never see those videos. I think that's got to be pushed too. We got to like find videos and like encourage people to, like, you know, if they want to, like, you know, record yourself, like, you know, showing your child something, you know, mathematically, you know, to kind of push back, or at least provide some balance between like the parents that are struggling or the people that, you know, want to make jokes and, you know, get likes and, you know, push content online and whatnot. You know, I just thought about that. Like, yeah, we don't see that as often.
Yeah.
And poverty can't be an excuse either. Because I remember back in the day, man, the mamas in the projects, they'll beat that tail if you wasn't doing right in school and if you wasn't getting good grades. It's not a matter of poverty. Like, people like to blame it on poverty. I've seen people that have a ton of kids and all of that, and they might be growing up in a low income area and all of that, but they still take their education serious. It's an individual basis. Like, you just gotta, to me, it was important, not just because I was an educator. I like spending time with my kids. So if I'm teaching you how to do football drills, how to catch a football, how to ride a bike, I'm teaching you something. So that, with like primary educators, when we say that, it's not just school, but I think it makes it simpler when you really take and spend quality time with your children to have those teachable moments. So then when it comes to things like academics, then you have a better, you can reach your child better than your school's teacher can half of the time.
Yeah.
Right.
Yeah.
I want to touch on that math marketing. I don't know if you guys, I'm sure you pay attention to it, but in every movie where anything comes up about school, it's always something negative about math. Anytime somebody has an issue in school, it's always math.
Yeah.
Every single time, even on shows, movie, whatever, books, it's always something about math. So I think it's kind of ingrained within society that we're going to have a challenge with math. That's number one.
Yep.
Number two, the memes that we're going to see about if Johnny has those memes that we know are about to pop up and they're going to flood us. I think there is also a deeper issue there. And I feel like it is people just being overwhelmed and stressed, because why else would you respond that way to your child? You probably overwhelmed with some other things in life. You probably didn't even really want to take it out on him, but this where we are right now. So I think it's probably something that is a lot deeper that's probably going on, because when I compare that to the videos where the children are flourishing, when they're toddlers doing, these multiplication facts with these large numbers, these parents is at the house, or they have very flexible jobs where they're spending all this time, like you just said, spending time with your kids. They're spending all this time. So the lifestyle is a little bit different. And I know you said poverty shouldn't play a part. To a certain degree, I do agree with you. The only piece is if a parent is working around the clock, you don't have time to kind of pour in. And that's gonna be what they say. I don't have the time. Whereas somebody who's a stay-at-home mom, baby, I can do whatever I need to do. Or if I got money, I got you a tutor on deck. You know what I mean? Like, just having the access to the tools and the resources, I think is a huge piece of it. Because even if I am not as strong in this or that, if I got money, then I can hook you up with a Kill or Dana or Lanisha or whoever else, and they can kind of do it for me. So I think maybe the primary educator piece, like you said, it doesn't necessarily have to be the content, but I think it is having access to the resources in the event that you don't feel that strongly there. Because I mean, the reality is everybody is not going to be able to sit down with their kid and do pre-calculus. At this point, with nothing else changed or done from where they are right now,
they on their own.
Everybody's not going to be able to sit down today and say, okay, boom, let's get to it.
But that's when you teach your child to advocate for themselves too. And as you were saying that, it makes me think about it a lot, especially for the folks that are in living in a certain poverty-stricken area or things like that. Let's just say it like this: if your child go to a Title I school, there's so many schools now where there's services for free tutoring. So that's another way that they can help find your child resources. Saying YouTube University, first of all, but check in with someone in the school and see what kind of tutoring services are offered. At the elementary school that I was at last year, we had a nonprofit organization, or actually I don't know if they're nonprofit or for profit, but there was this organization that they had professionals like not educators. These were people working in corporate America, that they would actually be the tutors for these students, and they were given space. I think a lot of them were from Bank of America, Wells Fargo, things like that here in the Charlotte area, but the actual tutors were corporate America workers. You know what I'm saying? So I think that makes it different as well, but it definitely is important for parents. If you don't have that kind of time, like, be intentional about, find a point of contact at the school. It could be the secretary at the front desk. It could be one of the assistant principal. It could be the principal. It could be the child's teacher. It could be the good teacher that they had last year that now they have a poor teacher. Miss Jackson ain't gonna mind if you reach back out to her and ask what kind of resources you can get for DJ, because he was thriving in second grade and now he's struggling in third grade.
Yeah. I think one thing, and I'm taking notes as you guys are talking. I think one thing that I'm getting that resonates with me is, as parents, we can't expect for everything to happen at school. So I think once we shift that mindset, that's going to change a lot. Another thing is stop pushing our experiences off onto our kids and verbalizing whatever negative relationships you may have with math, because then the kids are going to adopt that same belief for themselves. So I think if we just stop saying, I ain't no math person, I ain't good at math, whenever I was in school I did this, and that's gone, baby. Let's talk about something positive, because it's going to rub off on the kids. And then I think if we just set the tone, like be the model, so let them see you learning, let them see you figuring things out, because now, okay, like you said, YouTube University. If I'm not a child who is a go-getter, and I don't see nobody else in my house go getting anything, then I might not even think about the fact that I can go to YouTube to learn how to solve equations or figure out what domain and range are. I might not even think about that. I might only associate YouTube with watching somebody play games or Castanet or something like that. But now when I see my parents, oh, they going on YouTube because she's trying to figure out how to cook this, or she going on YouTube because she's trying to figure out how to build this or whatever. Now I'm looking at YouTube as a resource instead of just a form of entertainment. So I think kind of just, using ourselves as the model would be a great place to start.
Absolutely.
Okay. All right, y'all. We about to
lead by example. Lead by example.
Absolutely.
And it is a paradigm shift. It
is.
Yeah, it ain't nothing light. It ain't nothing sweet.
Right. Okay. All right. So my favorite part. So we have 3/4 here. I want to know, how would you represent your understanding of the following number? So obviously you guys would already know this. So let's just talk about some things that we would want to see our kids maybe jot down on their paper or share aloud with the class or a partner that demonstrates their understanding.
What's the unit? What? Go ahead.
4 total parts.
Okay.
What's the unit fraction?
Okay. So Dana, you're wanting them, they're going to demonstrate their understanding by saying that there are 4 total parts?
Yep.
Okay. And then Akil, you're saying they're going to demonstrate their understanding because they understand what the unit fraction is.
Part of it. That's part. I would say that's part of the process.
Okay.
That's one of the things I want them to be thinking about. What's my unit fraction?
What's my unit fraction? Okay. What's my unit fraction? All right. Anything else that you would look for or hope to see on their paper?
What is my math vocabulary? What's my denominator? What's my numerator?
Okay.
That is, yeah.
Okay. All right. So
wait, can I add something else?
Yeah.
This is what I want too. I want them thinking about the decimal equivalent and even the percentage equivalent. I want them thinking in terms of that too.
Got it. So equivalent representations. Got it. Okay.
Yeah.
So then so somebody's like, you would love it.
Got it.
You in there. So then Dana, if somebody draws this and does this, you in there. You love it. And then if somebody does this.
Now, yeah, they good with me.
You love it.
What grade we talking?
Well, I mean, if I ask any student, well, I'll say after 4th grade.
I don't think a 5th grader would understand the 3 times 1/4, but they would definitely understand. They should definitely understand the 1/4 plus 1/4 plus 1/4.
They wouldn't understand the 3 groups of
1/4? Well, you know what? Actually, so I'm thinking parentheses. I don't see them putting
the parentheses.
Because it's tough for me to get high schoolers to write parentheses still.
Got it.
You know what I'm saying? So if they wrote 3 and then the X 1/4, oh, they in there. Money.
Okay. All right, cool. Next, how are you expecting them to represent their understanding here? What are you expecting to see?
They got to know that it's larger than one whole.
Okay.
So, yeah, depending on what grade, I would like for them to show a picture.
Okay. So you want a picture?
And then to have the picture demonstrate why the mixed number equivalent is what it is.
Okay. Okay, so what would you expect to see in that picture?
So 3/3, 3 times, and then 1/3. I would do so we got four separate strip diagrams. If you want to do strip diagrams or rectangles.
Okay.
I do like 4 of them. And I really would like I would like for them to like be able to explain it to their class. Like draw it out, that's cool. But I like for them to explain it like why you gotta have 4 of them.
Okay.
Why can't you just have 1?
Okay.
Like what does that mean? And then also like how does the denominator play a part in this? And why does it? And also another like what makes this improper? We call it an improper fraction, but what's improper about it? What's wrong with it? Like what you trying to say? Like why do we call it improper? Like what is actually improper about it?
Okay.
Because improper could take on a negative connotation to some kids. Some kids, they don't have the wide variety of vocabulary all the time that we have. So maybe they only know that the negative connotation of improper is like, well, what's wrong with those kind of fractions?
Yeah.
Okay.
I remember thinking that. Like,
and that's what might make them connect and always want to write a mixed number. Because after a while, I tell kids, like once you get to 6th grade, you can leave it at that. Because they get in the habit of changing this to 3 1/3. And then it's like, wait, when you get to multiplying 10/3 times 2/3, it's like, yeah, it would have helped you better if you would have just had the, well, in my opinion, it's like, it's simpler to multiply the improper fraction in that state versus multiplying with a mixed number and things like that. But then again, that depends on your level of strategies of new math too.
Because they do distributive property, yeah. So originally I drew one long rectangle. If a child drew one long rectangle, what do you think? What do you think their mind is going?
I think they're thinking of maybe they've conflated like the numerator with the denominator. Maybe they're gonna have 10 sections in the long. Or maybe they're thinking they're gonna have 3 sections, but then they're gonna keep doing 3 sections over and over again within the one long rectangle until they have enough to shade in 10 of those.
Okay, so if I have 10 of these, then the value of each one would be what?
1/10.
For 10/3?
If you got 10 of them in one rectangle. Well, in one
rectangle. 10/3 is the same thing as what though?
3
1/3.
Right, but 10/3 is the same thing as 10 groups of what?
3. So you would have to draw other lines then. To me, if you got that long thing, now I would take each of those and break them down into like I would draw horizontal lines into those 10 spaces. You know what I'm saying? And then I would just color in one.
So I can't just label these?
You could.
Yeah, you could do that.
Could.
And then recognize that 3 of them.
Every 3 is a whole one.
Right.
Yeah.
3 is a whole.
You see how she did that Jedi mind trick on us? I forgot about that, and I know I got the fraction tiles that look just like that. But it's so. But what's cool about that is how that's another example of when we go back to the math person talk. We just think different sometimes. We approach different problems from different perspectives. And that's what kids have to understand. I think one of the things that concerns me about kids, right, is that this idea of time that's put on them. And so I think I always say this. I remember when I used to be young and my mama would be working with me on math stuff when I was in elementary school from time to time. And I would get to something that I couldn't remember and I would say, but when a child does something like that, or they're looking up in the sky or whatever they're doing, how do we know what's really going on in their brain? There's no way to tell. We don't, unless they verbalize it. And so we got to get kids to be talking, because when you said one long strip, I was like, I mean, I'm pretty sure it's possible, but I did not think in my mind to put the fraction on each section. But I was going, like I said, I would have took it down and drew them 3 horizontal lines in each section and shaded in one. So we would have had the same thing. It's just that you got the fractions on your diagram. I didn't. So some kids might put the actual fractions on their model. Some kids may not. They may get used to shading in sections.
Right.
And neither person is wrong.
Right. Okay. So what do we? This is our last one for this one.
Real
what do
quick,
we expect to see here?
Wait, real quick. I got a question though. So how could we, in regards to that, right? So how do we, how can we like do things to help kids show their understanding of things? Like what if we instead of giving summative assessments so often, we give formative assessments. It's kind of like the number talks and things like that, right? But what if that's a quiz? You know what I'm saying? Hey, show me on your paper that you know what 10/3 is. You know what I'm saying?
I like it.
Now, to me, I think it levels the playing.
You know, I feel like, and I think we might have talked about this before, but you know how they go concrete, representational, abstract, right? Well, that's what we're supposed to do, right? So hands-on, then your pictures, then your algorithms and things like that. That's what we're supposed to do. However, most of the time, kids are taken directly to the abstract. Based on my own experience, I'm gonna be honest with you. I feel like drawing is actually more challenging than the algorithm that kids are taken directly to. And I'm saying that because the point at which I'm dealing with kids is in middle school, and the algorithm is so ingrained in their brain, it's hard for them to think about drawing something. Like they will be sitting there stuck. Like, what do you mean? So I think when we skip that progression, I think it's very, very hard to get kids to go back. And I'm in the middle of my camp right now, and we have last week we had a 2.5 session of math. 2.5 session. I gave them breaks every now and then, but 2.5 hours of math, right? I didn't have any kids to check out. Like they was working the whole time. Nobody won't sleep. Nobody won't complaining. But it's small groups. It's a very small group. But they were in there figuring it out, and we needed that 2.5 hours so that they could change the way that they were processing stuff, because they wanted to go directly to, okay, let me just stack these numbers and add them, instead of thinking about, well, if I know that 8 plus 9 is 17, that I should automatically know what 18 plus 9 is because I only added 10. So instead of me going back to the beginning, I can just add on. You know what I mean? So long-winded to say that it's difficult for kids to take a step back and look at how to represent things. So I would love to do what you're saying and giving kids an opportunity to practice that more, instead of them going straight to, do you have this algorithm memorized?
The drawings are dope. Like as a student, like I didn't like drawing. I really wasn't taught that way. But then when I would find myself in situations where I was expected to draw, I didn't like to draw because I was like a perfectionist, and I wanted my drawings to be perfect. So that made me shy away from the drawings. But I think the drawings also become helpful because when you get to the algebra and it's time to graph equations, then you're much more like, you may be more comfortable with graphing, and showing the relationship, but showing the equation in that way, as a picture, because sometimes the picture just like, it does like make more sense. It's like, okay, I get it now, because like think about like algebra 2. We dealing with parabolas with like trajectories and the word problems with the basketballs or the rocket that take off. And it's like, when you realize like, oh, so this actual parabola actually models the exact way that the rocket is going to take off or the basketball is going to take off. Like, it's not even like a reach. Like, this is exactly how it's going to look. So, and then like plugging the numbers in, like finding the vertex and all that, like that's cool. But like, it's almost like it's like art class. When you understand it, it's like, okay, this is kind of chill, because it's like, I'm just drawing. I'm just chilling, just doing some drawings.
Right.
That's it. But I'm just following a model. So like, yeah, like I think that could like really, if they had that foundation in elementary school and middle school from like doing those math drawings, that could really be a nice like I guess segue into when they get to like the higher level classes and they're doing their drawings. And then I'm thinking, even now as we talk about it, I'm thinking about like a physics class where they got to do the diagrams and all that, chemistry when they're doing the chemical bonds, just being comfortable with just doing drawings.
Right. That's true. Yeah, relating that concept to a visual and getting like creating that muscle memory of doing that. Yeah.
And they eventually pull the rug from under the kids. We talk about concrete, representative, and abstract, but at a certain point, like it varies from school to school, the different resources and things like that. I won't get into all the other things teachers face during the summertime, but your stuff is not always in place when you come back to your room. But it's like at a certain point, let's say a kid is in a elementary school and their principal utilizes funding to make sure, let's say this principal says, hey, teachers, whatever y'all need as far as materials, let me know. And the teachers are vocal about it and they get these different resources, right? Well, that kid might go from elementary school and go to middle school and not be at a middle school. Like it's like, wait, what happened to the base 10 blocks? What happened to anything? Like, can we get some hands-on equations? I've been waiting. Well, I haven't been in a middle school in a while, but it's like, first thing I want to do, even in math 1, like, let's bring in this hands-on equations game.
Yeah, that's what
and they could do it on the phone or the iPad. You see what I'm saying? Now, like, I still show the video. It's a video when I'm helping kids learn how to solve equations. It's a scale, right? And if you move something from this, it's uneven. So what you do here, you got to do here. So now it's back up and boom, boom. So they get some of the kids, if they saw that representational things and if they were able to touch things and move things around all along, like up through 8th grade for sure, they will still be on track. Because it just, I don't know, it helps. It really helps.
For sure. Okay. So what would we expect to see here?
I would say you know what? A kid could do, like, we could do the models with the blocks again, and it would just be 2 fully colored, fully shaded blocks, and then a block that's halfway shaded. Okay. So they know that it's 2 full things and then a piece of something else, and that piece being that half.
Okay. What you thinking, Nikhil?
The conversion to the improper fraction.
Okay, so how would I represent that?
So I want them to write it. Just write it as a fraction with the denominator. Horizontal line fraction bar, 5 halves. I would also like to see the picture, the diagram. Only way it would be different from Dana's drawing would be, yeah, yep.
Yeah, exactly. Yeah. Yes.
So they would see 5 of them.
That's important.
All together.
Mm-hmm.
So that they see that there's halves in each block.
Mm-hmm.
Right.
Yep.
Like they need.
And then they also see, and then we can converse about the relationship between the mixed number and the improper fraction. Because we see we got 2 whole blocks shaded in, and we got half of a block shaded in. At the same time, that's 5 pieces shaded in.
Right.
Yep.
So your numerators are 5, and but each of those pieces is a half.
Mm-hmm. Okay.
So 5 halves.
The aha moment that a student had last week when they figured out why their teacher was telling them to do this, when they figured it out from the picture, like, oh, that's why we multiply those and add that, because it's actually 5 halves. That's why we do that. When she had that aha moment and her eyes kind of like lit up, I was like, yeah, that's what we're here for. That's what we're here for. Okay. So I asked this question, and I posted this in a video. Akil responded to it on TikTok. I asked the kids last week, what facts do you know that could help you evaluate this expression mentally? Akil said something about, in his comment, something about your inflexibleness impacted your kids' flexibleness. I think it was something like that. What'd you say?
Yeah. Like my because you were talking about flexible strategies, and I was like, man, like early in my teaching career, I was very inflexible. I had my ways that I did problems, and then like I didn't really get into like other ways. I was like, nah, this is the way we do it. That's why I go so hard with like having like multiple methods. It's like, nah, you need as many methods as possible. Because I remember just early on, like, nah, I would just be like, listen, this is the way you do it. This is how we're gonna do it. And this is how I'm teaching you. So you gotta learn this. Like, so I just be like,
right
nah,
here.
yeah, we need as many strategies as possible because I want you to be able to pick and choose. Because that's a skill in itself. Like being able to recognize when you should use which strategy.
That part. So what facts what facts do we want kids, if we ask them this question, what do we want the responses to be?
I want a child to know what 7 times 7 is.
Okay.
I want a child to know what 7 times 100th is.
Okay.
So place value.
Okay.
Place value. I want them to know place value. Those would be the 2 things for me. With the TH.
Okay. All right. So then if I know what 7 times 7 is, how does that even relate to this?
The way I would do it.
Go ahead, Q.
Well, the way I would think, I'm thinking money. I'm thinking 0.007 is 7 cents.
Okay.
So then I'm like, and this I'm gonna say something else about this after I explain this. It's like I would want them to think, okay, 7 cents 7 times, so they know that. Hopefully, they know the 7 facts, and then they're like, okay, well that's 49, but that's 49 cents. My concern is though, we're getting into an era where everything is becoming very electronic, even money. Do children still go to the store with change or even cash? And if they are, is it as frequently as we did? I wonder about that. So I'm wondering about like if relating it to money or to cash or to like, metal coins will be as helpful for some children. If they don't have that
relative too, based upon where they reside at. You know what I'm saying? Back in Oakland, my kids, they walk around the corner to the corner store. You know what I'm saying? So they probably gonna have cash. You know what I'm saying? But even still, you go to the Aki store, yeah, you might take some cash in there, but you still tap. I'm always looking for the tap. Versus if the store around the corner from you is a Food Lion, it's a little different. You might, mama send you to the Food Line or the Walmart, she might give you the debit card. You know what I'm saying? And to your point, how much cash are they handling? All right. your child is young. You want to teach them about finances. Oh, okay, I started you a bank account. Now you got a debit card. Now your child turns 16. You don't want to give them no cash because you don't have no cash to give them, right? Hey, I just transferred $20 to your debit card. Go buy this, this, and this from the store. So that's a good point, because I used to get frustrated when I would say, how many decimal points is involved in money? And they're like, I'm like, yo, when you write money, how many digits is to the right of the decimal place? And they're like, oh, 2. Yeah, but so that does affect things, I think, a whole lot, man.
Yeah.
This era of technology really does affect that. And I think that sometimes I think we have the more space to explain that and break it down as teachers in the home versus a teacher in the classroom, because I don't think that sometimes the powers that be consider those little things. It's like, hey, we're gonna it's like so many things are normed, you know what I'm saying? And so it's the assumption that kids know place value by the time they're in 3rd grade, because the standard in 2nd grade said they should know place value. We assume that they learned it, and they don't always learn it.
Right.
They might have been taught it, but they were just being confetti sprinkles of information on their head. You know what I'm saying?
Right. One thing about that is, no, I have encountered a lot of kids that the only money that they know is quarters. And sometimes you might can ask a student and they might not even be able to tell you that a quarter is 25 cents. They might not even be able to tell you that. So as you guys were stating, location probably is definitely relevant, but this whole technology wave is definitely changing the way that we kind of meet them where they are, because where they are now is not where they were before. So, or where children were before. But to this point, if they know 7 times 7 equals 49, then how can we reason about the product of the second
one. I like Akil's process. You know, if we know that 700 is like 7 cents, then we can, like, for example, you can draw a picture and have 7 cents 7 times, or
Okay.
we can reason, because a kid is probably not going to, they're not gonna always know. Like, this is, you gotta. I question, like, okay, is this at the point of 6th grade where we're actually multiplying decimals? You know what I'm saying?
Mm-hmm.
What kind of decimals are we multiplying? But when we talk about reasoning, I think it starts with them knowing that there's 7 groups of something that has this value of 700s.
Okay.
So if they could start there, if they know that there's 7 groups of 700s, then we can get them somewhere.
Okay. So I want y'all to I want you to look at this. So what is the relationship between the first factor in the first expression and the first factor in the second expression?
Like 7 times a 0?
What's the relationship for this and this?
Oh, they're the same.
Which means the relationship is we're doing what?
Multiplying by 1.
Okay. What's the relationship between the second factor in the first expression and the second factor in the second one?
We multiply by 100.
So then what should be the relationship in our product?
We multiply by 100.
So in terms of like a conceptual understanding piece, because if I take these, 1 times 100 equals 100, like that's the relationship between the two expressions. So them understanding the place value, and then, oh, boom. That's how when people say, oh, it's 2 decimal places, or it's 2 places after the decimal, they're telling you that this is now the reasoning behind it, if that makes sense.
Yeah.
Yeah. Okay.
And
That's good enough.
that's important, because it's a lot of that now. Like, I think that goes back to kind of the conversation we were having the other week, where they can see that 100th is a fraction. It's also a decimal.
Mm-hmm. What about this one? We talking about facts. What facts could the students use?
25 facts. Well, if we know 25 facts, that's kind of rare.
Yeah.
Yeah.
Okay. So that means we can relate this back to what you were saying earlier. If the child knows it.
About the money, about the pennies. It's 4
Yeah,
pennies.
because automatically when I see 25 times any 4, I think $1, and then
Right.
figure out how to break up that dollar. And
Mm-hmm.
kids these days, that's not always in their mental Rolodex.
You right about that.
I mean, it's just a fact of life.
Mm-hmm. Okay. Anything else? Any other facts? I'm gonna put down what you said before, like the place value piece. And then hopefully they should know that it's gonna be hundredths place. And then we talked about on the previous slide why it would be the hundredths place.
Right.
Yeah.
I'm trying to remember, like, there's, and I did a video on this for my channel, and I should remember this. But there was a method that I saw in the textbook I use where they said, well, what happens if the child forgets? Because, you know, if you follow the traditional multiplication algorithm, multiplying 0.04 times 25, and then you forget the step where you say, okay, which tells you where to put the decimal point at the end of the problem. There's a way you you think about, okay, well, the first factor is in between these two numbers, and the second factor is in between these two numbers, or in between these two whole numbers. So therefore, and then you multiply those numbers together. And then, yeah, I gotta look into that. I gotta look that up again. Because it kind of relates to this, because it's like, yeah, it's definitely related to this, because it's almost like you're treating that 0.04 like it's not even a decimal. Because when we multiply, we're not really using the traditional algorithm. We're not really treating it like it's a decimal. We don't even really, the decimal point don't even come into play until you get your final product, and you got to just decide where it goes. But it's like based on what numbers the factors are in between, then that should tell you like, okay, where the decimal point will go. Because if the like 20, I guess we think 25 times 4 is 100, but it can't be 100 because, let's see, 0.04 is in between, I guess 0.04 is in between 0 and 1. So it's like saying 25, oh, maybe this is it. 25 times 0 is 0, and 25 times 1 is 25. No, that's not it. That's not it. I got to look that up.
Look it up and share it with me, because I want to see it too.
Now this is going to bother me now.
Don't let it bother you right now.
I gotta look that up. Yeah, tonight.
But I want to see it. So when you find it, please share it in the chat. So all right, we're gonna go ahead and go to this one. So now we dividing. So we are comparing, and we're gonna wrap this up. We're comparing these. What facts do you want kids to know that could help them solve this if they don't know how to divide by decimals?
I want a kid to understand what even numbers can do. So identify the difference between even numbers and odd numbers, right? So if I know that's an even number, 352, and I'm breaking it into 2 parts, I want them to know that I should get a whole number.
Okay.
And I like that diagram you put in there like that.
All right. Okay, what you thinking?
352 divided by 2. Reasonable effects about fractional numbers. I'm thinking, well, okay, I want them to recognize that the digits are the same, right?
Right.
And but also recognize that the decimal points are just in different places. But if the decimal points So what's the relationship between 2 and 0.2? 0.2 is 1/10 of 2. But if we were dealing with like 35.2, which would also be 1/10 of 352, then we would get the same answer.
I got a problem like that too.
It's similar to like that, the same difference method in subtraction. When you like, in order to avoid having to borrow, you just, you change the number, you like maybe add 2 to one of the numbers. What is it? The minuend to make the minuend bigger. And then, but you also add 2 to the subtrahend. You end up with the same distance between the two numbers. To that.
So I'm just writing down some different things that you guys are saying and how it's sparking thought for me. So Dana said something about understanding that if we're dividing by 2, then we have 2 equal groups, and we're talking about whole numbers. If it's an even number or whatever, it's a whole number. So I'm looking at, I broke it apart in 350 and 2, and possibly the student would know how many times 2 goes into 350 based on how many times 2 goes into 35, maybe. I don't know. What y'all think?
So I like that, but I looked at it actually. I broke it down into 352.
Yeah.
352.
I think 300 is a friendlier number than 350.
Okay.
Yeah, I'm doing partial quotients with this one.
Yeah.
Okay.
So I would do that 300. Oh, okay. I know 300 is broken down into 150 and 150. So boom, I got my 150. And then 52. I might not know 52, but I know 50 is broken down into 2 groups of 25. And then I know if I take that 2, it can only be put into 1 group of 2.
So boom.
Yes. And then add up those partial quotients.
So I know I got 176 for the first one. So now knowing that the quotient of 352 and 2 is 176, how do I use that to reason about where the placement of my decimal is in my quotient?
So now if I take that same diagram, I'm gonna put a decimal. So it's gonna be 3.00. I like that because a lot of kids don't always understand it. 3.00 is the same thing as just 3. Even something as simple as that, a lot of times kids struggle with understanding. I could take a number and change it to a decimal by just putting a decimal and a 0 to the right of it. You know what I'm saying? So then I would do the same thing for the 50. I would make that 5/10, but I would keep the 0. And then take the 2 and make that one now this one you got to add the 0 and boom. So then now, okay, how many digits are between? So in that first partial quotient, right, I got 300 becomes 3.0, so the 150 becomes 1.5
if we divide it by 2, right?
Yes.
Okay, so we're gonna go to the dividing by 2 and then go here, or what we doing?
I would say the dividing by 2 and then go. What then you would still with that same degree. I'm sorry, diagram. You would have to change that that 2 to a 2/10. But I would do the divide by 2 first, and then take that. So take that and then go back and put my decimal in the proper place from that partial quotient.
Got it. Okay. What would you do, Akil?
With the 3.52 and the 0.2, I'm thinking of money. So I'm thinking of 0.2 as like 20 cents. So I would do partial quotients, but I'm breaking it up into 3.40 and 0.12.
Okay.
So how many 20-cent increments can go into 3.40, which is what, 17? So 17, and then I have 0.12 left over. So how many 0.2s can fit? So, but then the question is like, how do I express that?
Okay, so while y'all processing this, I'm gonna do the same thing I did for the last one. What is the relationship between 352 and 3 and 5200ths?
You multiply by 1 over 100.
Okay, so if I got 100 divided by 1/10 What does that equal?
1/10.
Which means this should be multiplied by this to get the quotient for this.
17.6.
So what do we say to the parent that's looking at us go through this and they like, man, you got to do all this. And I bring that question up for a reason, because I want a parent to see that, yes, it looks like a whole bunch of going around your elbow to get to your thumb.
I knew you was about to say that.
But everything that we just talked about was different pieces of number sense that kids could have. Because you got like, even for me, this multiplying by a fraction, my mind don't work like that. I divide. You know what I'm saying? I had to unlearn and relearn that. Now I like even until my mind just don't naturally go to the multiplying by a fraction.
Got it.
You know what I'm saying? We're doing the same thing, just a different way. And so I think that parents should see all these different things, but this is also why it's important to encourage kids to write neatly. The difference between scratch paper and showing your work. There's some things that don't even never need to hit your paper that you turn it in. You see what I'm saying? We got to encourage kids to go back to writing down stuff. Everything kids sitting there, oh man, I'm teacher talking for 90 minutes and you think you ain't learned nothing. That stuff just shooting off the top of your head. Boom, boom, boom.
Right.
And so they got to understand that there's a connection. You remember 30% more of what you write down versus what you just hear.
Right.
That's my soapbox for tonight.
The only thing, and I agree with you, that somebody is gonna say, because I remember whenever I posted this the other day, in the comment section, in my caption, I said, my friend Dana is gonna say you going around your elbow to get to somewhere. I can't remember what I said. You going around your elbow to get somewhere. I already knew it. I put it in there. But I think it's so, like, if a kid has this level of numeracy, like if I understand the relationship between numbers, because math to me is a lot about relationships and patterns. Now you talking about, why do I need to change my divisor to a whole number and going through this, where I haven't been in a classroom yet where I heard anybody explain it to a point where any child understood why they need to do that. Have y'all been in the classroom where somebody explained why I need to make the divisor a whole number when I'm dividing? I ain't been in one yet. So I'm just thinking about what are other ways that we can get students to do the same thing using understanding versus me giving you a set of rules saying you got to do this. And I understand there's some levels of mathematics where a rule is just what I'm going to have to give you. Like, the higher up you go, they say the less intuitive some of the stuff is. That's what they say. That's what they say, whoever they is. So I understand that sometimes there is going to be a rule that is going to have to be given. But if we at the point where we can use some sense, some understanding, then I'm like, let's go for it. The problem is we don't always have enough time in the classroom to really get to this level, this depth of understanding. So
I think on the front end, it seems like it's more work, but like, and sometimes it might be on the front end, but like once you develop that number sense and that numeracy, like it makes things much easier long term, just like for life.
Yep.
Like it's just front end work versus like, do you want to do the work on the front end? So like on the back end, it's a lot easier. Right. Because if you don't learn this, and I think that too, like when people say, why do I have to do this? It's like, wait, you don't have to, but if you do, then math in general is going to be just a lot easier.
Yep.
Going along, because once you get in the habit of understanding these types of relationships between the numbers, you're going to start to recognize relationships between numbers.
Right.
Figure out your own shortcuts. You can figure out your own shortcuts.
Right.
And I think that's how we give the students, like we are helping them fill up their toolbox by showing them these things. By taking that longer route, I am now helping you to develop a way for you to look at things differently, as Akil was saying. So now when you get down the road, you may come up with something that is more efficient for you or something that is quicker for you. But it's because we took the journey. We ain't take the sprint. And now you won't have the ability to come up with nothing on your own. But I have two of these in here, and you actually mentioned this earlier. Like if we look at the relationship between these two, what's the relationship between 604 and 60 4/10?
So it's time 1/10
And then the relationship between 4 and 4/10
times 1/10.
So if we know that both of these have this relationship, that means that their answers, their quotient should be what?
The same.
They should be the same. So boom, already. I ain't got to worry about, oh, I need to make 4/10 a whole number. I don't have to worry about that. Because if I can figure out what 604 divided by 4 is, I know exactly what 60 4/10 divided by 4/10 is.
And I'm a partial
When we
quotient.
get rid of the house, you know what I'm saying, to divide, because this makes me think about that. I don't see much of the old school, I call it the house, where the dividend is under the bar, and then like I'm seeing less and less of that in like textbooks and things in the schools.
They supposed to do this. They're supposed to learn this in 6th grade. They start off with partial quotients, and then they go to the long division.
Yeah, I'm all about, but yeah, I'm with this. But again, number sense, I'm looking at it. I'm like, all right, watch this. I'm like, I can imagine myself being in like elementary school or middle school and be like, again, looking at it like it's a game. Because I'm like, well, I know if I break up that 604 into 604, and I'm like, well, why would I do that? Oh, because I know 60 is divisible by 4. So if 60 is divisible by 4, then 600 is divisible by 4.
Right.
So 60 divided by 4 is 15. So 600 got to be 150. And it's just 1 4 left over. So I'm straight at it. 151.
Boom. Done. Just like
I
that.
know. But these
just
are
like
but
these all of this goes back to what we said at the beginning, kind of. There's always going to be certain facts that if a kid, the basis and the foundation of number sense, after learning what numbers are and learning the value of numbers, is learning those relationships, even when we're talking about those math facts. You see what I'm saying? If a kid didn't know that 60 was divisible by 4, then how he's going to struggle with understanding that 600 is divisible by 4. Right. He may have some math anxieties, but if he knows that thing right there, he's going to start being like, wait, whoa. It's just another 0 added on there. You know what I'm saying? And before they know it, kids will be doing mental math without even knowing that they're doing mental math.
Right.
So if a student, okay, let me ask this then. If a student does not know how many times 4 goes into 60 or 4 goes into 600, do we expect them to, you think that partial quotients would be a better place for us to start? Like here?
I would ask them, so I would ask them if they don't know, like if they don't know that 60 is divisible by 4, I would say, I would possibly think, I see what you're saying. No, so I was about to answer a different question.
I'm just wondering, where do we then, okay, boom, you don't know that one? You don't know this fact? Okay, let's work with what we do know. So then the partial quotient, because I'm sure you know what 4 times 10 is.
Yeah.
So now what's 4 times 100? Okay, so then now we got 4 times 50, right? 200. And now what's left? 4 times 1. Boom. So what's the quotient? 151.
151. 151. When I see 151 brings back some bad memories, by the way.
When I see a kid that struggles with division, I'll ask the question, like if a kid said, if they have, we're solving an equation and it's like, you got to divide by 20 on both sides and they're not sure. I say, well, I'll take the denominator and say, so this denominator times what number equals that numerator? And interestingly enough, some kids understand it and they're like, wait, okay, so I understood it from the multiplication side. I didn't realize because I knew the multiplication side, I actually know the division side as well. And so that's one of the things that I like about this type of problem, because kids don't often know that, like, yo, if you know some multiplication, you actually know some division too.
Right.
Nobody's really explicitly telling you that. a lot of times.
I was thinking about that the other day when I was working on integers and reasoning about multiplying positive and negative numbers, and then using that to help kids understand dividing positive and negative numbers instead of just telling them the rule, like them being able to see it. So then what you just said, like if I were to multiply these, I know I would get this type of product. So if you understand the multiplication of it, now just apply that in reverse, essentially. But okay, so I've held y'all hostage long enough. So let's get into the wrap up. We've done been up here for an hour and 26 minutes. So what is something that you can leave the people with after we've talked about all that we've talked about tonight?
I would say just the point that, you know, when people see, because like when you did that video, and I think I shared it on my page on Facebook, and then one of my Facebook friends commented, like kind of like one of them comments, like what in the hell is all of that, right?
I didn't see that.
I want people to understand. I want people to understand that whole idea of like that front end work. The front end work makes the back end so much easier, like long term, right? Mm-hmm. And also, like it looks like a mess. It does, but when you I was looking at the screen when you were doing it, it really made me think of like, you know, prepping for the cookout. Like when I go to my mom's house and my sisters are cooking and my mom is cooking, and like the kitchen is a mess. Like it's stuff all over the place, you know. Mm-hmm. But that's what you gotta do. You gotta do to, like, you know, prepare the meal. Or like Thanksgiving, the kitchen gonna be a mess. The paper gonna be a mess. The screen gonna be a mess. But that's part of it. That's just part of it. You know, and we gotta. But again, once you develop that understanding and that muscle memory, then it's like you're not doing that much anyway. And I think that's another thing too that, like, I'm sure y'all experience is like when you're explaining something to somebody in a detailed manner, step by step, it's always going to be longer than when somebody actually understands it and has committed it to memory and they're just doing it. Mm-hmm. And I try to, because we try to be thorough when we explain things. If we explain it the way we actually do it, it wouldn't take that long at all. But then you wouldn't understand it. You wouldn't understand it because you don't know what I know. So when I'm taking my time and I'm giving it to you step by step, you know, like you can't have it both ways. Because if I made it short, you wouldn't understand it. You know, if I do it the lengthy route, if I go the lengthy route, then it's like I'm doing that so you can understand it. So we got to focus on the fact that we're trying to gain the understanding. We're trying to help you to gain the understanding, and then it's gonna be shorter anyway.
Right.
You know? So yeah, but I think that's a lot of that is just, you know, the math anxiety that kicks in, that takes over. You know, and people just looking for reasons to like not do it and to like shy away. Yeah.
Don't tap out. Tap in. Tap in. Yeah. Dana, what you got?
I think from this, my wrap up would be to the parents: encourage your kids to write down their reasoning, their mathematical reasoning as they're working through a problem, as well as verbalize it. Because sometimes some kids are able to verbalize it more than they're able to write it down, but they go hand in hand. I always tell kids, because I think kids sometimes they want the language to be right when they're speaking on it. And I tell them all the time, just say it how it comes to your mind. Mm-hmm. I'm a good interpreter. I can turn it into the mathematical language. Mm-hmm. So if you're working with your kid and let's say they're talking to you out loud about their reasoning and the steps that they're taking, maybe let them talk and you write down, you annotate what they're saying, mm-hmm. and then y'all are able to have the conversation to connect the two, because now we build this skill for the kids that can write it down. Because a lot of times the ones that aren't as strong verbalizing it, like Akil said, sometimes anxiety, sometimes they're shy. They don't like speaking in front of the class and things like that, but create that space for them to be able to connect what they're writing with what they're thinking, and as well as be able to speak it. If you can build that bridge, that will really help them in the long run.
I want to follow up what you just said. You said the student is talking and then the parent is annotating or they're making the notes. I think that would be a really cool exercise to see if what you're communicating comes off in the way that you intend for it to. So like when they see the picture that the parent draws, now, is this what you were meaning? Like, how can we, what changes do we need to make it match what you were thinking in your head? Like, I think that is like a cool, super cool exercise. Thank you for sharing that. All right, so my wrap up is, I want to hint a little bit on what Akil was saying earlier in terms of things looking like a mess. Like, I think that we overall have to build our stamina for things. Like, I think we tend to want things to come very quickly. I just want to get straight to it. And I see this a lot with working with students who are in advanced classes. They don't want to learn nothing about no concept. Baby, just give me the algorithm because I'm about to go. Okay. I don't want to learn nothing else. I know how to do the algorithm. That is all I need. And I think that we need to build our stamina, because that's a layer of discipline that I feel like if we have, it's just going to distribute out or spread out to other areas in our life, and it can only make us better. So if I could add anything, I want parents out there, if you're listening, you come across this video, I want you to build your stamina as a parent, taking the time to slow down and model for your child the things that you want to see in them, so that they can then build their stamina for things, because we got to put in the work. We make comparisons to athletics and sports all the time. These superstar athletes ain't just wake up and go out there and they just magically, superstars. They putting in work, and the work ain't always pretty. So I want us to apply that same thought process to mathematics and just school learning overall. Again, I thank you guys so much for spending this time with me. I have really kept y'all a long time tonight, and I appreciate it. I do not take it for granted. Thank everybody who is watching and engaging with us. I appreciate you all as well, as we come to you guys tonight, hoping that we impart something on you that helps you to bud and bear fruit, because you guys can get into all this math, because you and your children are capable of being young gurus. Until next time, peace.
Deuces.